Hey guys, welcome back to my channel. Hope you all are fine. So, today we are going to deal with the chapter mole concept. Okay, mole concept. This is a one shot of mole concept, and this is a part one of the mole concept. Okay, part one of the chapter mole concept. So, firstly, we are dealing with atoms and molecules. So, atom means one element like oxygen, sodium, iron, sulfur are atoms. In case of molecule, more than one atom is present, right? So, O2. In case of O2, two atoms of oxygen is present. In case of NaOH, that is sodium hydroxide, one atom of Na, one atom of oxygen, and one atom of hydrogen is present. FeO, that means iron oxide. In case of iron oxide, one atom of Fe and one atom of oxygen is present. In case of SO2, sulfur dioxide, one atom of sulfur plus two atom of oxygen is present. Okay, so this is all about atoms and molecule. Only one atom is present, only one element is present in case of atom, and in case of molecule, more than one element is present. Okay, so there are two types of molecules, homoatomic and polyatomic. Homoatomic means only one or same type of atom is present in the molecule. Polyatomic means more than one type of atom is present. That means homoatomic means in case of example is O2 and O3. O2 means two atoms of oxygen present, and that means same atom is present. More than one type of atom is present in case of polyatomic. Means carbon dioxide is an example. One molecule atom of carbon and two atoms of oxygen present. In case of H2O, two atoms of hydrogen and one atom of oxygen. NaOH have one atom of sodium, one atom of oxygen, and one atom of hydrogen. So one more than one type of atom is present in the polyatomic, and only one type of atom is present in the homoatomic. Okay, then comes atomicity of the molecule. Atomicity of molecule means number of atoms present in a molecule. So in case of carbon dioxide, there are three atoms. That means one carbon plus two oxygen, right? So and in case of H2O, one hydrogen plus two oxygen is present. Okay, so atomicity of molecule, number of atoms present in a molecule. That means in case of P4 means phosphorus 4. 4 is the atomicity. That means 4 atoms of phosphorus is present, and type of molecule is homoatomic. Homoatomic means only one type of atom is present. That is only phosphorus is present. And then SO2. In case of SO2, one sulfur plus two oxygen. That means 3 is the atomicity. 3 atoms are present, and that is heteroatomic. Heteroatomic means more than one type of atom is present. In case of H2SO4, atomicity is equal to 7. H2SO4, in case of H2SO4, 2 hydrogen plus 1 sulfur plus 4 oxygen is present. That means 2 plus 1, 3, 3 plus 4 is equal to 7. Total 7 atoms are present. That is heteroatomic. That is more than one type of atom is present. In case of sulfur 8, 8 is the atomicity. That means 8 atoms of sulfur is present, and it is homoatomic. Homoatomic means only sulfur is present. Only sulfur atom is present. That means it is homoatomic. And then topic 2, electron causes the chemical reaction. Electron is the cause for the chemical reaction and reason for the chemical reaction. Proton causes the nuclear reaction. Okay, nuclear reaction occurs due to proton, and a chemical reaction occur due to electron. So atom, in case of atom, atomic number is equal to Z. Atomic number means number of proton. Atomic number means number of proton. Okay, what is atomic number? Atomic number means number of proton, and mass number means number of nucleon. Mass number is represented by A, and which is equal to number of nucleons. Mass number means number of nucleons. Number of nucleons means number of protons plus number of neutrons. Okay, number of nucleons means number of protons plus number of neutrons. Okay. So, atom atomic number Z is equal to number of proton, mass number A is equal to number of nucleons, which is equal to number of protons plus number of neutrons. This is the first topic: atom, molecule, homoatomic, polyatomic, atomicity, and atom. In an atom, Z is the atomic number, that means number of protons. Mass number is the number of nucleon, that means number of protons plus number of neutrons. Subatomic particles: electron, proton and neutron are subatomic particle. Electron is discovered by J.J. Thomson. J.J. Thomson discovered electron and mass equal to 9.1 into 10 raised to minus 31 kilogram, which is negligible, which is a very small mass, right? So, which is negligible, which is equal to minus 1, charge is equal to minus 1.6 into 10 raised to minus 19 coulomb, relatively equal to minus 1. Okay, relatively equal to minus 1. In case of proton, so electron discovered by J.J. Thomson, mass equal to 9.1 into 10 raised to minus 31 kilogram and charge equal to minus 1.6 into 10 raised to minus 19 coulomb. In case of proton, Goldstein or Rutherford discovered proton and mass equal to 1.6 into 10 raised to minus 27 kilogram, which is approximately equal to mass of neutron. Mass of neutron is also equal to 1.6 into 10 raised to minus 27 kilogram, and mass of proton is also equal to 1.6 into 10 raised to minus 27 kilogram. And the charge of proton equal to 1.6 into 10 raised to minus 19 coulomb, and charge of neutron equal to 0. And neutron is discovered by James Chadwick. So, electron discovered by J.J. Thomson, mass equal to 9.1 into 10 raised to minus 31 kilogram, charge equal to minus 1.6 into 10 raised to minus 19 coulomb. Charge of proton equal to plus 1.6 into 10 raised to minus 19 coulomb, and charge of neutron is equal to 0. That means neutron is neutral. Neutron is neutral. And then mass of proton equal to 1.6 into 10 raised to minus 27 kilogram, which is approximately equal to mass of neutron. Mass of proton and mass of neutron is equal, that is 1.6 into 10 raised to minus 27 kilogram. James Chadwick discovered neutron, and proton discovered by Goldstein or Rutherford, and J.J. Thomson discovered electron. Okay. Then topic 3 is mass number is equal to A. An atom is represented, an element is represented by X, A, Z. Okay, and the A is the mass number and Z is the atomic number. Z is the atomic number, means number of proton, and mass number means number of neutrons plus number of proton, which is together known as nucleons. Okay, A is the mass number, which means number of protons plus number of neutrons, and which is together known as number of nucleons, and Z is the atomic number, which is equal to number of protons. Okay, so an atom is represented. So here is the example for an atom: chlorine 1735. Chlorine 1735. Atomic number Z is the atomic number. This is the atomic number. 17 is equal to Z equal to atomic number, and 35 equal to A equal to mass number. 35 is the mass number and 17 is the atomic number. Okay, 35 is equal to A equal to mass number. So atomic number equal to number of proton equal to 70. So mass number equal to number of proton plus number of neutron, together known as number of nucleon, equal to 35. And number of neutrons. So we already knew that A is equal to number of neutrons plus number of protons. A equal to mass number equal to number of neutrons plus number of protons. So number of neutrons is equal to A, that means mass number minus number of protons. Here number of neutrons equal to 35 minus 70. 35 is A, that means mass number minus number of protons. Okay, number of neutrons equal to mass number minus number of protons. Okay, and then number of electron. Here chlorine 3517 is a neutral atom. So in case of neutral atom, number of electrons equal to number of protons, and this is an way to find number of electron. For a neutral atom, number of electron equal to number of proton. For a neutral atom, number of electron equal to number of proton. That means chlorine 3517. In case of chlorine 3517, number of electron is equal to number of proton. That means it is a neutral atom. Chlorine is a neutral atom. So in case of neutral atom, number of electrons is equal to number of proton. In case of anion, what is meant by anion? If in a neutral atom, if an addition of electron takes place, chlorine is a neutral atom. Okay, neutral atom means number of proton equal to number of electron. The number of proton and number of electron is equal in chlorine. If an addition of electron takes place, if an electron is added into chlorine, it means chlorine minus. Okay, one electron is added, that means chlorine minus. So in chlorine minus, number of electron, it is known as anion. Okay, if an addition of electron takes place into an atom, that ion is known as anion. Okay, it is turned into an ion. That is, ion is known as anion. So in case of anions, number of electrons equal to number of proton plus charge on ion. Okay. In case of chlorine minus, the number of proton, number of electrons is equal to number of proton plus charge on ion. Here the charge is equal to 1. Okay. Number of proton plus charge on the ion. And then another example, oxygen is a neutral atom. Neutral atom means number of proton equal to number of neutron. If two electrons is added into oxygen, it is oxygen 2 minus, O2 minus. Okay, 2 electrons is added into oxygen. So number of electrons is more than number of proton. That means total number of electrons in neutral atom, proton equal to electron. In if 2 electron is added into oxygen, total number of electrons will be equal to total number of proton plus 2 plus 2, total number of proton plus 2. Okay, total number of proton plus 2. In case of O2 minus, number of electrons is equal to total number of proton plus 2. That means 2 electrons is added. Okay, and anions, number of electrons is equal to number of proton plus charge. This is the charge, 2 minus is the charge on the anion. And what is meant by cation? Cation means if loss of electron takes place, that atom is turned into a cation. That means in case of Na plus, Na plus, an electron is lost from this. Na is a neutral atom. That means number of proton equal to number of electron. And then if an electron is lost from this Na, it will be like Na plus. An electron is lost from this. That means electron lost means it uh, is a plus charge. Okay, first equal to plus charge equal to minus charge. If an electron is lost from that, it will turn into 1 plus charge is dominating, right? So Na plus. Na plus means in case of Na plus number, that means it is a cation. Na plus is a cation, and then number of electrons is equal to number of proton minus charge on the ion. That means here charge is equal to 1. Here charge equal to 1. Here charge equal to number of proton minus 1. Here charge is equal to 1. And another example. Mg. Here Mg, magnesium, number of proton equal to number of electron, and Mg2 plus, 2 electrons is lost from here, number of electrons equal to proton, number of proton minus charge, that is proton minus 2. Okay, in case of cation, number of electron is equal to number of proton minus charge on ion. In case of anion, number of electron equal to number of proton plus charge on the ion. Okay, next, isotopes. Isotopes means same number of proton. If two atoms have same number of proton, H11, H12, okay, is the example for the isotopes. That means here Z, that is atomic number or number of proton is same. Okay, mass number is different. Here 1 is the mass number, here 2 is the mass number. Okay, so isotope means same number of proton or atomic number, and isobar means same number of nucleons, that is mass number is same. If mass number is same, that is, if A is same, that is isobars. And isotons means same number of neutron. How to find the number of neutron? Mass number minus number of protons. Okay, so if mass number minus number of protons is same in two elements or two atoms, it is isotons. Isotopes means same number of proton. Isobars means same number of nucleons, that is A is same, here Z is same. And then isoelectric species means isoelectronic species means isoelectronic. Okay, isoelectronic species means same number of electrons are same. Okay, electrons are same. If electrons are same, it is isoelectronic species. In case of Na plus, Mg2 plus, it is isoelectronic species. That is, the electrons in these two atoms are same, ions are same, in these two cations are same. And F minus, right? 10 electrons is present in both. That means number of protons. Sodium has 11 protons and sodium plus. So number of electrons 11 proton, that is atomic number is equal to 11. Magnesium atomic number equal to 12. That is number of electron in case of Na plus equal to number of proton, that is 11 minus 1 plus. So minus charge on the ion, that is 11 minus 1 is equal to 10. And in case of Mg2 plus, 12 is the atomic number, that is 12 minus 2 plus. 2 plus means minus 2, that is 2 is the charge, that is 12 minus 2 is equal to 10. That is in both these number of electrons is same, so isoelectronic means same number of electron. Isosteres means same number of electrons and same number of atoms. That's not very important. Same number of electrons and same number of atoms are present, it is isoelectronic species. Okay, electrons and same number of atoms. And then um, if isodiapers means same difference between proton and neutron. That is number of proton minus number of neutron is equal to same. It is isodiapers. If number of electrons is same and number of atoms is same, that is isostere. Okay, and in case of H2SO4, the atomicity is equal to 7. Atomicity equal to 7 means 2 hydrogen atom, 1 sulfur atom and 4 oxygen atoms, right? Atomicity equal to 7. So, 1 hydrogen has proton H11, S sulfur 3216, oxygen 16 8. We have to find number of electron, number of proton and number of neutrons in this compound. We know how to find the number of electron, proton and neutron in atoms like oxygen, sodium, right? Fluorine. Okay, so we have to find the in the molecule. Okay, find the number of electron, number of proton and number of neutrons in the molecule. So H11, number of protons in hydrogen 11 is equal to 1 and number of electron is equal to 1. For neutral atom, number of electrons equal to number of proton, and neutron is equal to number of neutron equal to A minus, sorry, A minus number of protons. That is in case of H11, A is equal to 1 minus number of protons equal to 1, which is equal to 0. Okay, in case of sulfur 3216, Z equal to number of proton equal to 16 and a number of electron equal to 16 and a number of neutron is equal to A minus P, that is A is equal to 32 minus 16 is equal to 16. Okay, number of neutrons is also 16. And in case of oxygen 16 8, number of proton equal to 8, number of electron equal to 8, number of neutron is equal to A minus Z, that means 16 minus 8 equal to 8. Okay, so there are two atoms of hydrogen, so one atom has one proton, and so in H2SO4 two hydrogen is present. So we have to find the number of electrons totally. Okay, in case of electron, we have to mark this line. Okay, electron equal to 1 in hydrogen, 1 in 1 hydrogen, 1 is the electron. So in 2 hydrogen atoms are present, that is 2 into 1 plus uh, 1 sulfur atom is present, that means 16 electrons is present in sulfur atom and 8 electrons in oxygen atom, but 4 oxygen atoms are present. So total 1 in 1 oxygen atom 8 electrons, total 4 oxygen atom, 4 into 8 which is equal to 32. Okay, plus 32, that means 50 electrons will be present, 50 electrons will be present. Okay, similarly protons, in case of proton we have to mark the first one. In one hydrogen one proton equal to present, and then in case of two hydrogen 2 into 1. Okay, and then in case of sulfur one sulfur atom one proton, that means plus 16 proton plus total 4 atoms of oxygen, that is one atom has 8 proton. So 4 atom has 4 into 8 equal to 32 plus 32 means 50 protons. And then comes number of neutrons. Number of neutrons. We have to mark this. Hydrogen has 0 neutrons. Okay, hydrogen has 0 neutron. Total 2 hydrogen. That is 2 into 0 plus 2 into 0. And one sulfur has 16 neutrons. 16 plus 4 oxygen atom. One oxygen atom has 8. 4 oxygen atom has 4 into 8 is equal to 32 neutrons. Okay, that means 48 neutrons is present. Okay, 2 into 0 equal to 0. 16 plus 32 equal to 48 neutrons are present. Okay, so this is the way to find. Firstly, you have to write H11, sulfur T216, oxygen, individual atom, number of neutrons, electrons and protons in individual atoms, and then you have to find the number of each atom, that is 2 hydrogen, 1 sulfur and 4 oxygen, and you have to find the total number of electrons, protons and the neutrons. Okay, this is the way to find. And then 1 mole means 1 mole particle means 1 mole, anything 1 mole means 6.022 into 10 raised to 23. That means 1 mole atom means 6.022 into 10 raised to 23 atoms. 1 mole molecule means 6.022 into 10 raised to 23 molecules. 1 mole of packets means 6.022 into 10 raised to 23 packets. 1 mole chocolates means 6.022 into 10 raised to 23 chocolates. Okay, anything 1 mole means 6.022 into 10 raised to 23. That means Avogadro number of particles. Okay, Avogadro number of particles are present in 1 mole. Okay, Avogadro number of particles are present in 1 mole. And for 1 mole, 6.022 into 10 raised to 23. For 2 mole, 2 into Avogadro number. 2 mole means 2 into Avogadro number. Okay, 2 into 6.022 into 10 raised to 23 particles. Okay, here is the example. 2 mole H2CO3 is present. So H2CO3, total number of electrons, protons and neutrons in H2CO3. Hydrogen has 1 electron, that is 1 into 2 plus 6. Carbon has 6 electron plus 8 into 3. Oxygen has 8 electron into 3 oxygen atoms, so which is equal to 32. Proton 1 into 2, 1 proton in hydrogen into 2 plus 6 uh, protons are present in the carbon plus 8 into 3 which is equal to 32, and neutron 0 into 2 plus 6 plus 8 into 3, that is 30. Okay, so in case of H2CO3, 2 moles of H2CO3 means 2 into 6.022 into 10 raised to 23 molecules. That means H2CO3 are molecules. So H2CO3, 2 into 6.022 into 10 raised to 23 molecules, or 2 into Avogadro number of molecules. 2 into Avogadro number of molecules. 6.022 into 10 raised to 23 means Avogadro number of particles. Okay, 6.2 into 6.2 mole means 2 into 6.022 into 10 raised to 23 molecules. That means 3 mole means 3 into 6.022 into 10 raised to 23 molecules. 1000 mole means 1000 into 6.022 into 10 raised to 23 molecules. Okay, so 2 mole, 2, the number of atoms in of hydrogen, 2 atoms of hydrogen are present in the H2CO3, right? So totally 2 moles are present. Total 2 moles are present, and uh, 1 mole has. So total number of hydrogen 2 into 6.022 into 10 raised to 23 molecules. Okay, so number of hydrogen atom, 2 hydrogen atom, 2 hydrogen atom into 2 Na atoms of hydrogen. That is for 1 mole. For 1 mole, 2 atoms of hydrogen is present, but for 2 mole, 2 into 2 Na atoms of hydrogen, that is 2 into 2 Na. Okay, 1 carbon atom, 1 into 2 Na atoms of carbon, and 3 oxygen atom, 3 into 2 Na. You have to write this. 2 mole means 2 Na, 3 into 2 Na. If 2 into 2 Na, 2 into 2 Na, 1 into 1 into 2 Na. And the number of electrons equal to 32. Total number of electrons equal to 32 into 2Na. 2Na means 2 mole. That means 2 mole has 2 Na electrons. Okay. 32 into 2 Na protons, 30 into 2 Na neutrons. Okay. If it is 3 mole, you have to write 3Na. 3Na in case of 2Na. Okay. If it is 10, 100 moles, if it is 100 moles, you have to write here 100 into 6.022 into 10 raised to 23 or 100 Na. 100 Na. Okay. So you have to erase this 2Na. So you have to erase this 2Na. Like in case of this 2Na, if 100 moles are present, you have to mark as 100 Na. That means the total number of atoms of hydrogen is equal to 2 atoms of hydrogen, 2 into 100 Na. Total number of carbon atoms will be 1 into 100 Na, and 1 into number of molecules into Avogadro number, right? Number of atoms into number of moles into Avogadro number. Okay, number of atoms into number of moles into Avogadro number. This is the format. Atomic mass. Atomic mass is the mass due to proton plus neutron plus electron. An atom has proton, neutron, and electron. So atomic mass is the mass due to proton plus neutron and electron. We already knew that electron has the mass 9.1 into 10 raised to minus 31 kilogram, which is negligible, okay, in compared to proton and neutron, okay, minus 31 kilogram, okay, which is negligible. So mass number means atomic mass is equal to, we have to find it, mass number into mass of one proton or neutron. Mass of one proton or neutron is equal to 1.6 into 10 raised to minus 24 gram or 1.6 into 10 raised to minus 27 kilogram. Mass number is equal to number of proton plus neutron. Okay. So here is the equation: atomic mass equal to mass due to proton, neutron, and electron. And electron, we have to it is negligible, so we have to avoid it. So, and then mass number is the number of proton, total number of proton plus neutron into mass of one proton or neutron, which is 1.6 into 10 raised to minus 27 kilogram. And it's easy to understand through an example. And then atomic mass unit, AMU, or unified mass equal to 1 by 12 into mass of one atom of carbon 12. 1 by 12 into atomic mass unit or unified mass is equal to 1 by 12th part of the mass of carbon 12 atom. Carbon 12 atom has some mass, and 1 by 12th part of the mass of carbon 12 atom is the 1 AMU. Okay, it's a definition for 1 AMU. 1 AMU, the value will be 1.6 into 10 raised to minus 27 kilogram, which is equal to 1.6 into 10 raised to minus 24 gram. So we can do it with an example. Oxygen 16.8. In case of oxygen 16.8, 16 AMU, we can write this mass in three format: 16 AMU or 16U. Okay, 16 as atomic mass unit or 16 unified mass, or we can write it as 16, or we can write it as 16 gram. Okay, three has different things. 16 AMU or 16U is the mass of one atom of oxygen. This one atom of oxygen has the mass 16 AMU or 16U. Okay, mass of one atom is equal to 16 AMU or 16U. If we have to convert it into gram, if mass of one atom We know that mass of one atom is equal to 16 AMU or 16U. Okay, one atom. Okay, one atom is 16 AMU or 16U. So if we have to convert it into gram, 16 AMU or mass of an atom into gram, we know the equation that 1 AMU is equal to 1.6 into 10 raised to minus 27 kilogram. So 16 into, this is the mass of one atom, 16 into 1.6 into 10 raised to minus 27 kilogram. Okay, 16 into 1.6. 16 into 1.6 into 10 raised to minus 27 kilogram. This is the gram. 1 AMU, it can be converted into 1 to gram, okay, by multiplying it with 1.6 into 10 raised to minus 27 kilogram, as 1 AMU equal to 1.6 into 10 raised to minus 27 kilogram. So firstly, this is the mass of one atom. This is the mass of one atom, okay, and then relative 16. Then next is the 16. Okay, this is 16. Okay, the 16 is equal to mass number. Okay, this is the relative atomic mass. The 16 AMU or 16U is the actual atomic mass, means that is the mass of one atom of oxygen. 16 is the mass number, that is relative atomic mass. Relative atomic mass equal to mass of one atom of an element, that is mass of one atom of oxygen. How can we find the mass of one atom of oxygen? We know that oxygen has protons plus neutron plus electron. In that we can avoid electron because its mass is negligible as 9.1 into 10 raised to minus 31 kilogram. So proton mass is, which is equal to mass of proton plus mass of neutron. Mass of proton plus mass of neutron means mass of proton mass of proton plus mass of neutron means number of protons into mass of one proton. Mass of one proton. Mass of one proton is equal to 1.6 into 10 raised to minus 27 kilogram. And plus number of neutrons into mass of neutron. Mass of proton and mass of neutron is approximately equal. That means uh, we can write it as mass of proton. Okay, so mass of proton plus mass of neutron is equal to, we can write mass of proton is approximately equal to mass of neutron, right? So we can write it as mass of proton. So mass of proton into, we can outside bring it outside of the bracket, number of proton plus number of neutrons, that is mass of proton into number of neutrons plus number of protons. Like mass of proton into number of proton plus number of neutron, right? So which is equal to mass of proton, number of proton plus number of neutron is equal to mass number, right? Mass number. So we can write it as mass of one atom of an element is equal to, in case of oxygen, mass of one atom of element means mass number into mass of proton. Okay, mass number into mass of proton divided by 1 by 12 into mass of one atom of carbon 12. One atom of carbon 12, the mass is equal to mass number into mass of proton. 1 by 12 into 12 is the mass number of carbon 12. Carbon 12, the mass number equal to 12 into mass of proton. Mass of one atom of carbon 12 equal to 12 into mass of proton. Okay, so 12 mass of proton which is equal to mass number. So you don't have to study this, you have to only study like mass. So mass number is equal to relative atomic mass. If you are asked to find the relative atomic mass, you have to write the mass number. Okay, you have to write the mass number. Relative atomic mass equal to mass number. In case of sodium 1123, the relative atomic mass will be 23. In case of aluminium 27, the mass number will be 27. Okay, like that. So mass relative atomic mass equal to 27, that is the mass number. Relative atomic mass is equal to mass number. Okay, relative atomic mass, you have only studied this line, relative atomic mass equal to mass number. If you are asked to find the relative atomic mass is equal to mass number. Gram atomic mass means the atomic mass expressed in the gram. Okay, this gram atomic mass is the mass of one mole atom. Okay, this is the mass of one mole atom in gram. That here AMU 16 AMU or 16 U is mass of one atom. Here the mass of one mole atom, that means 6.022 into 10 raised to 23 atoms mass. Okay, this is the mass of 6.022 into 10 raised to 23. 16 gram is the mass of 6.022 into 10 raised to 23 atoms. Here 16 AMU is the mass of one atom. Okay, 16 gram is the mass of 6.022 into 10 raised to 23 atom, and 16 AMU or 16 U is mass of one atom. Okay, so you have to note the difference. Gram atomic mass is the mass of one mole atom in gram, which is the mass number expressed in grams. Mass number in grams. If you are asked to find the gram atomic mass, you have to simply write the mass number in gram. Okay, gram atomic mass means mass number in gram. That is mass of one mole of atom of an element, mass of 6.022 into 10 raised to 23 atom of element. So firstly, we had already said that 16 AMU or 16 U is the mass of one atom of oxygen. One atom mass is 16 AMU or 16 U, and mass of one mole atom is 16 gram. Okay, so 16 AMU or 16 U, convert it into gram, means 1 AMU, in case of place of 1 AMU, we can multiply it with 1.6 into 10 raised to minus 24 gram. Okay, or 16 into 1.6 into 10 raised to minus 27 kilogram. Okay, mass of one mole atom is equal to 16 gram. Okay, we don't have to multiply it with AMU or write like that things. Okay, 16 AMU or 16 U is equal to mass of one atom of oxygen is equal to actual atomic mass, and 16 AMU can be converted it into 16 gram. 60 can be converted into gram by 16 into 1.6 into 10 raised to minus 27 kilogram. This can be converted into kilogram, and this is the mass of one mole atom of the oxygen, 16 gram atomic mass. Relative atomic mass means mass number. Okay, and the Avogadro number into AMU. Avogadro number multiplied by AMU is equal to 1. That means 1 AMU is equal to 1 by Avogadro number. 1 divided by 1.6022 into 10 raised to 23, which is equal to 1.6 into 1 AMU is equal to 1.6 into 10 raised to minus 24 gram. That is, you have to study this. 1 AMU is Na, that is Avogadro number multiplied by AMU is equal to 1. 1 AMU, that is 1 atomic mass unit, is equal to 1 divided by Avogadro number. 1 divided by 6.022 into 10 raised to 23, which is equal to 1.6 into 10 raised to minus 24 gram. You have to learn this. Avogadro number multiplied by AMU is equal to 1. And then comes, in case of molecule, the carbon dioxide, 12 is the mass of carbon plus 16 into 2 oxygen, 16 into 2, that is 44 is the mass number of the carbon dioxide molecule. Relative molecular mass is the mass number. Relative molecular mass equal to 44. Simply relative molecular mass equal to 44. And mass of one molecule of carbon dioxide is the actual molecular mass, which is equal to expressed in 44 AMU or 44 U. The actual molecular mass of one molecule of carbon dioxide, mass of one mole or mass of Avogadro number of molecules of carbon dioxide equal to gram molecular mass, 44 gram. Okay, relative molecular mass means simply mass number. Actual molecular mass, that is mass of one molecule of carbon dioxide, is 44 AMU or 44 U. 44 gram is the gram molecular mass or mass of one mole molecule. 1 mole molecule 44 gram, 1 molecule 44 AMU or 44 U. Okay, mole calculation. The number of moles equal to given mass of element divided by molar mass of element, and number of molecules is also equal to given number of particle divided by Avogadro number. This molar mass of particle means if the particle is, that is mass number, means mass number gram molecule. This gram atomic mass is also known as molar mass. This gram atomic mass is also known as molar atomic mass or molar mass. Molar atomic mass or molar mass, that is mass of one mole atom or mass of one mole molecule. This gram molecular mass is also known as molar mass. That is mass of one mole particle is the molar mass. Mass of one mole particle is the molar mass. Okay, mass of one mole particle is the molar mass. Molar given mass of X element divided by mass of molar mass, that is mass of one mole. 1 mole particle, that is in case of oxygen it is 16, in case of sulfur it, in case of sulfur molar mass equal to 32. Okay, in case of carbon dioxide molar mass equal to 44. Okay, and then number of moles, another method is given number of particle divided by 6.022 into 10 raised to 23. If number of particles is given, we can simply find it by dividing it with 6.022 into 10 raised to 23. And if given mass is given, we can use this equation. If number of particles is given, we can use this equation. For gases, there is another equation. Number of moles is equal to given volume of element divided by molar volume. Given volume of element divided by molar volume. Molar volume depends on temperature and pressure. Molar volume depends upon the temperature and pressure. Molar volume is the volume of 1 mole of any gas. Volume of 1 mole of any gas is the molar volume. At 273 Kelvin and 1 atm pressure, 22.4 liter. Okay, 22.4 liter we can take at any situation as 22.4 liter. You don't have to study this, but if particular question, you have to take molar volume as 22.4 in all cases. Okay, 22.4 liter in all cases, but you just simply read this at 273 Kelvin. If particular question is given like 273 Kelvin and 1 bar pressure, the molar volume will be 22.7 liter. But you can simply take 22.4 liter as molar volume. Okay, you just read this. Okay, 22.4 liter is the standard molar volume. You can take this at any condition in the question. But if the question is to find the molar volume at 273 Kelvin and 1 bar pressure, is to find molar volume. If the question is to find number of moles and in the question it's not given the molar volume, we can simply take 22.4 liter as the molar volume. If it is not mentioned in the question, the molar volume is not mentioned, you can simply take 22.4 liter as the molar volume. If in the question it is mentioned to take 22.7 liter as the molar volume, you can take it as 22.7 liter. Okay, And then atomic mass can be fraction in case of isotopes. Okay, atomic mass is not always a whole number, it can be fraction also. Okay, in case of isotopes it is fraction. So in case of isotopes you have to find average atomic mass. Isotope, like in case of chlorine, 35.5 is the atomic mass of chlorine. Chlorine has two isotope, chlorine 35 and chlorine 36. Okay, so 35.5 is the and hydrogen has three isotope like protium, deuterium and tritium. H11 isotope means same number of protons, right? H12 and H13. Okay, same number of protons. Okay, this is the percentage abundance. Average atomic mass is equal to sigma atomic mass into percentage abundance. Percentage abundance means how much abundant it in the earth. Okay, divided by 100. Okay, average atomic mass equal to sigma atomic mass into percentage abundance divided by 100. So for example, in case of an element X, X25 has percentage abundance 30 percentage, X30 has 60 percentage and X35 has 10 percentage abundance. So average atomic mass equal to 25, that is atomic mass 25 into its percentage abundance, that is 30. 25 into 30 plus 30 atomic mass into 60 plus 30 into 60 plus 35 into 10 plus 35 into 10, that is 25 into 30, 30 into 60 plus 35 into 10 divide by 100. We can get the answer. Okay, this is the average atomic mass equation. To find average atomic mass, this is equation sigma atomic mass into percentage abundance, that is atomic mass into percentage abundance, 25 into 30 and 30 plus 30 into 60 plus 35 into 10 percentage. Okay, then comes the law of chemical combinations. First law is the law of conservation of mass. Mass is conserved. Mass can neither be created nor be destroyed. That is, mass can neither be created nor be destroyed in a chemical reaction. In a chemical reaction, the mass is always conserved. That is, if a reactants is converted into products, mass of reactants will always be equal to mass of products. Okay, mass of reactant will be always be equal to mass of product. If A plus B is converted into C plus D, mass of A plus B, that is the reactants, will be equal to mass of C plus D. Okay, mass of C plus D equal to mass of A plus B. This is the first law, that is law of conservation of mass. The exception for this is the in case of nuclear reaction is equal to, in case of nuclear reaction equal to mc square. There is an exception in nuclear reaction, the mass is not conserved. Okay, mass is not conserved in the nuclear reaction. You will study it later in the physics chapter. Okay, nuclei chapter. And then law of definite proportion. Law of definite proportion means irrespective of the source, a chemical compound has element in a fixed ratio of mass. That means if I take water from the river, okay, if I take a water from river in a vessel, and in another vessel if I take water from a sea, and in another vessel sea, if in a vessel I take water from river, if in another vessel I take water from the sea, and if in another vessel I take water from the pond, so these all contain water. And water has hydrogen and oxygen. Water, the formula is H2O, hydrogen and oxygen. In all these vessels, that is from the river, from the sea and from the pond, in all these vessels, the hydrogen and oxygen ratio is 2 hydrogen is to 1 oxygen. 2 hydrogen is to 1 oxygen. In all these, the ratio of the element will be same. Okay, irrespective of the source. This is from river, this is from sea, this is from the pond, but 2 hydrogen and 1 oxygen is present in all these. That is, the mass of 1 hydrogen is, that is mass of 2 hydrogen is 2 is to 16, that is 1 oxygen is 16, 2 is to 16, that means 1 is to 8, 2 is to 16, 2 gram of hydrogen is present for 16 gram, that is 1 is to 8. Okay, mass is same irrespective of the source.
a chemical compound has element in a fixed ratio of mass, that is the ratio of mass is fixed, that is 2 hydrogen is to 1 oxygen. 2 hydrogen, 1 hydrogen has mass 1 gram, 2 hydrogen has 2 gram is to 2 gram means expressed in the gram, that is 2 mole. 2 mole hydrogen has 2 gram and 1 mole of oxygen has 16 gram. If one atom of hydrogen has 2 AMU, one atom of hydrogen has 1 AMU, 1 mole of hydrogen has 1 gram, 2 mole of hydrogen has 2 gram, 1 mole of oxygen has 16 gram, 1 atom of oxygen has 16 AMU. This 16 gram, 1 mole of oxygen. 2 gram is to 16 gram means 1 is to 8 is the ratio. 1 is to 8 is the ratio. This is the law of definite proportion. Irrespective of the source, a chemical compound has element in a fixed ratio of mass. And then law of multiple proportion. Law of multiple proportion means ratio of atom combined is whole number. That means you have to take this example. Here the carbon monoxide, carbon plus oxygen combined to form two different compounds, that is carbon monoxide and carbon dioxide. Carbon plus oxygen combined to form carbon monoxide and carbon dioxide. Here carbon is taken as a fixed mass. In both the compound the carbon is taken as 12 gram. In both the compound the carbon is taken as 12 gram, but the ratio of oxygen differs, that is 16 is the ratio of oxygen in first one, that is 1 oxygen 16 gram, 2 oxygen 32 gram. 16 is to 32 give a whole number, that is 1 is to 2. So, carbon plus oxygen combined to form two different compounds, that is carbon monoxide and carbon dioxide. Here we are taking carbon, the mass of carbon is fixed, that is 12 is the mass of carbon in both. Okay, 12 is the mass of carbon in both, that is carbon, the mass of carbon is fixed in both. Okay, and the mass of, when we compare the mass of oxygen and mass of oxygen, the mass will, we will get a simple whole number ratio, that is 1 is to 2. This is the law of multiple proportion. If two atoms combine to form, if two or more atoms combine to form two different compounds, and if we take the mass of one of the atom as fixed, so the mass of the another atoms will form a simple whole number ratio. Okay, if two or more atoms combine to form more than two different compounds, if we take the mass of one atom as fixed, the mass of other atoms will be in a simple whole number ratio. Okay, this is the definition of law of multiple proportion. And Gay-Lussac's law, gases combine in a simple whole number ratio of volume, that is here 2 hydrogen gas plus 1 oxygen gas gives 2 H2O gas. The volume will be like 2 means here if it is 2 liter, here it is 1 liter, here it is 2 liter, that is it will combine in a simple whole number ratio of volume. Here it is 2, so 2 liter. It's, if I will say like, if hydrogen is taken as 4 liter, okay, 4 liter, if hydrogen is 4 liter, oxygen will be half of hydrogen, that is oxygen will be 2 liter, but the water formed, that water vapor formed will be 4 liter. Okay, like that, 2 liter, 1 liter, 2 liter. Okay, so if 4 liter, half oxygen will be taken as half and the water vapor formed will be 4 liter. And then comes Avogadro law. Avogadro law means equal volume of gases contains equal moles of gases or equal molecules of gases, irrespective of the gases. Okay, if I am taking in this vessel carbon dioxide, 10 liter carbon dioxide, 10 liter carbon dioxide. If in this vessel I am taking 10 liter nitrogen, here I have carbon dioxide, here I have nitrogen, both are 10 liter. Okay, then volume of gases will be proportional to number of moles. The number of moles in both of this will be same. The number of moles in both of this will be equal, right? If this is 10 liter and this is also 10 liter, and the number of moles will be like 10 divided by 22.4. We already said to find the number of moles, the given volume divided by molar volume 22.4. Okay, here this is 10 divided by 22.4, this is also 10 divided by 22.4. in case of gases, okay, this is in the case of gases, and number of molecules will also be 10 divided by 22.4 into Avogadro number. Okay, that is one mole has Avogadro number of molecules. So 10 liter carbon dioxide has 10 divided by 22.4 number of moles. That is, number of molecules will be 10 divided by 22.4 into Avogadro number of molecules. But atoms will be different. Atoms here we have 3 into 10 divided by 22.4 into Avogadro number. In case of 10 liter N2, the number of moles will be same, 10 divided by 22.4, 10 divided by 22.4, here also 10 divided by 22.4. Number of molecules will also be same, here 10 divided by 22.4 into Avogadro number, 10 divided by 22.4 into Avogadro number. Number of moles into Avogadro number is the number of molecules. But number of atom, here we have 2 into 10 divided by 22.4 into Avogadro number. So Avogadro's law means, if I am taking hydrogen, this is hydrogen, this is oxygen, this is nitrogen. I am taking this as 100 liter each. 100 liter hydrogen, 100 liter oxygen, 100 liter N2. So the number of moles will be equal to, number of moles will be 100 divided by, of hydrogen will be 100 divided by molar volume, that is 22.4. And in case of oxygen, given volume divided by molar volume, it will be 100 divided by 22.4. Here also 100 divided by 22.4. Okay, and number of molecules will be, number of molecules will be equal to number of moles into Avogadro number of particles. Number of moles into Avogadro number of particles, that is Avogadro number of molecules. Okay, that means 1 mole carbon dioxide contain Avogadro number of carbon dioxide. 1 mole oxygen atom contains Avogadro number of oxygen atoms. So 100 divided by 22.4 mole hydrogen contains 100 divided by 22.4 into Avogadro number of hydrogen. Okay, so this is the part 1 of the mole concept. So hope you enjoy this video. So if you like this video, don't forget to like, share and subscribe. Thank you.